Very good evening to all of you. We will try to discuss more about the negative feedback closed loop system and the effects of it. So, yesterday we have seen that the negative feedback is going to the negative feedback will increase the bandwidth. Now, this is the figure, or you can say the curve for the bandwidth of any system. Now, normally bandwidth means what? This is the range of frequencies for which the gain is constant. You can see that between FL and FH, the gain is a constant value, and below FL the gain will reduce with a certain slope. I think this is already discussed in the integrator and the differentiator, and you can see here again beyond FH the gain will also reduce. Normally this curve is plotted in the semi-log paper because the gain will reduce in terms of decade. Like suppose if I take this as minus 20 dB per decade. Now we'll try to understand this, that when you increase the frequency in decade, that is 1 hertz to 10 hertz or 10 hertz to 100 hertz, then your slope will reduce by 20 dB. dB means decibel. So normally this slope will be in terms of dB per decade, because we are going to vary the frequency in tens, that is in decades. So by using a negative feedback, you are going to increase the bandwidth. It means that you are going to incorporate more frequencies for which the gain will remain constant. Obviously the gain will be decreasing. You will not be having the same gain. I think the curve will be like this now. So the curve will be like this. You can see here more number of frequencies has been incorporated in the bandwidth. So by using this feedback, you can increase the bandwidth, but with the reduced gain. So okay, so coming down to our equations. So now I think this is the higher cutoff frequency and this is the lower cutoff frequency, above which the gain will remain constant and below which the gain will remain constant. I think we have already studied these two equations in the integrator and the differentiator, or you can say in the low pass filter and the high pass filter. What is low pass filter? Low pass filter means what? This is the gain. Suppose this is the frequency, this is the gain. So this low pass filter will pass only the lower band frequencies, and this low pass filter will attenuate the higher frequencies. Now talking about the high pass filter. Now high pass filter will block the lower range of frequencies, and this will pass the higher range of frequencies. So now if you just combine these two, you will be getting the band pass filter. So what you can say that this is the band pass filter, because you are going to pass only the band of frequencies. Okay, so when you are having this type of curve, so you will come across these two equations. Now first we will write the gain in terms of the higher cutoff frequency, and the second we will try to write the gain in terms of lower cutoff frequency. Normally the higher cutoff frequency will always be in the denominator of the frequency ratio, and the lower cutoff frequency will always come in the numerator. So this is the normal thing. I think this is the basic thing which we need to understand when you want to find the effect of the negative feedback on the bandwidth. Okay, so now coming down to this. Okay, now what is AF? You can see that when you are having the negative feedback, so your gain will change. Initially in the open loop system it was A, and when you are going to incorporate a negative feedback, that time the gain will be reduced by the factor, that is 1 upon 1 plus A beta. Fine. Okay, so now A means what? This is the A value. Okay, first we will take the higher cutoff frequency, or you can say lower cutoff frequency. Okay, so AF will be equals to A upon 1 plus A beta. So we will write A in terms of our frequency, because right now our main intention is to increase the lower and is to decrease the higher, is to increase the higher cutoff frequency and to decrease, you can see there, is to increase the higher cutoff frequency and decrease the lower cutoff frequency. This is our main intention. You just want to, you can see here, you want to increase the cutoff frequency here and you want to reduce the cutoff frequency here. Okay, so now you can see, just we will be putting all the values A0 upon 1 plus J FL upon F. Okay, so this will be the thing. So now if you take the LCM of it, this 1 plus J FL upon F, this will come here. Now you just rearrange the equation, A0 upon 1 plus A0 beta plus J. Fine. So what you will do now? So this will be A0 upon, you just take this one as a common, then you will be having 1 plus JL F upon A, 1 plus A0 in beta. So okay, so this one means what? With feedback. This is the with feedback value, right? And this is also, you can see here, the FL is a constant value. You can see FL is a constant value. It will be in terms of a time constant. That will be a constant value. So A0, this will be A0F. Okay, so just you can see here, your FL upon 1 plus A0 beta, your lower cutoff frequency reduces. So I think we got the value of it. Okay, so now coming down to the higher cutoff frequency. Now we will focus our attention on the higher cutoff frequency. So this is higher cutoff frequency. AF will be equals to A upon 1 plus A beta. Again, you just put out the value. Okay, in terms of higher cutoff frequency. Okay, now again take the LCM of it, 1 plus A0 beta. Again you take a common out of it. That will be 1 plus J F upon 1 plus A0 beta FH. So let A, this will be the value, and FH. So you can see that this is coming, you can see that there is no division, there is a multiplication here, 1 plus A0 beta into FH. So you can see that the higher cutoff frequency will increase. So you can see that you are going to increase the bandwidth. You can see FH will change from FH to FHF, and this lower cutoff will change from to FLF. So this is all about the advantages of the negative feedback amplifier. So all the advantages are very fruitful to us, but the only drawback which we face in the negative feedback is about the overall strength of the gain, right? Because in the open loop it was A, and in the closed loop or negative feedback it is A upon 1 plus A beta. Okay, thanks a lot for your kind attention.